1 math. Lesson 21 is about divisibility, or how what we divide by to get to a number. So what are the factors that we could find for a given number? This would be for numbers that'd be composite as opposed to the prime numbers that we've learned about, right? Because it needs to have, this will be a good test to see if a number is composite or prime. So there are ways of discovering whether some numbers are factors of other numbers without actually having to go through all the guess and check using your calculator and all that jazz. For instance, we know that all evens can be divided by 2. So you just, if you see it's an even number, you know 2 is one of its factors. And to know it's an even number without dividing by 2, it ends in one of these digits. 0, 2, 4, 6, or 8. Okay, so a lot of this lesson is going to have to do with that last digit and what we have to do with that. And that's right here, the last digit tests. Inspect and see if the last digit is even, then it's divisible or divisible by 2. It has another factor, it's composite. Okay, that's the easy one. We probably knew that one already. How about ending in 0 or 5, such as 10 or 500? Those must be divisible by 5 if they end in 0 or 5. 505 would be divisible by 5. Okay, that means by 5. And 10, last digit, 0. So the powers of 10 end in 0. With me so far? Review. Okay, we're coming up with quick tricks and tests to find whether something's divisible. It's very useful. Add the digits of the number can tell us whether it's divisible. These are called sum of digit tests. It's divisible by 3 if the digits sum to 3, add up to 3. Let me show you an example. If they add up to a number divisible by 3, let me show you an example. 93. Divisible by 3, not so much because it ends in the number 3, that doesn't always work, but you take these digits, 9 and 3, you separate them as if they were both worth a ones digit. 9 plus 3 is 12, and you ask, is 12 divided by 3? Sorry, 3? Yes, it would come to 4. It comes out even, therefore 3 worked for that number. Another one would be, I don't know, 48. 4 plus 8, separated as digits, is 12. Again, divisible by 3. 9, same thing, only divisible by 9. So, let's see. If the sum of the digits is divisible by 9, let's try 18. So that would be 108. Except 0, it's not worth a 10, it's just 1, so that doesn't work. How about, I have to think about, well, let's just use the example to be our good example. I'm not come up with a good idea right now. Let's look at the divisible by 9 examples. 135, would that be divisible by 9? 135, so we separate it out, do the divisible by 3 and 9 test, which is the sum of digits test, just like that, because it's 135, separated as a 1, 3, 5, add them up, what's the sum? 9. Okay, obviously divisible by 9, so that was an easy one. Also, if it's going to be divisible by 3, it has to be divisible by, or by 9, it has to be divisible by 3. What about 2? Nah, it doesn't end in 0, 2, 4, 6, or 8. But what about 5? Does it end in 5 or 0? How about 10? End in 0? So answer is 3, 5, 9. Will the product of any two prime factors of 135 given above also be a factor of 135? Product of any two prime factors of 135 given above also be a factor of 135. Think about that to yourself. Prime factorization of 135. You could do 5 and, let's see, and then you've got another 6, 26, 2 and 13. And let me read this. Will the product of any two prime factors, even if I choose, let's say, the 2 and the 13, will they be a factor? Oh, I see. So 2 times 13. Yep, 26. How about 2 times 5? No, 10 does not work. 5 times 13, 75. Again, I'm not sure if that's going to work. So I'm thinking no right now to that question. That's just what I'm thinking. How about divisible by 2 tests? You feeling good about those? Divisible by 3? Let's try this one. To find out if 2,345 is divisible by 3, you add up 2, 3, 4, 5. You can do that in your head. 14. Now, is 14 divisible by 3? No. Therefore, it is not divisible by 3. Okay? That's how we do these, and it's a lot quicker than typing them always into your calculator. It just makes you look smart. So, why don't you show me the rest of those lesson practice, please?